20 ME 302 Engineering Thermodynamics. So here we discuss about all 5 units lecture video. So the unit 1 is basic concepts and first law of thermodynamics. So before we go that we have to discuss about the all 5 units. So here is the syllabus for 20 ME 302 Engineering Thermodynamics. So the unit 1 is basic concepts and the first law of thermodynamics. So here we discuss about the basic concepts and thermodynamic system, property, state, path, functions, zeroth law and the first law of thermodynamics, and as well as open and closed system. And the unit 2 is second law, entropy and availability. The second law which discuss about the Kelvin, Planck and Clausius statement, as well as Carnot cycle, reversed Carnot cycle theorem, and as well as heat engine efficiency like refrigerator and heat pump. So these are all the topics we have to discuss about in unit 2. And for the unit 3, properties of pure substance and steam power cycles. So here what are the pure substance, what are the phase rules, and the PV, TS diagrams, HS diagrams, and as well as ideal and actual ranking cycles, improvement method, reheat and regenerative cycles. And the unit 4 is ideal, real gases and thermodynamic relations. Here we discuss about the ideal gases and real gases, as well as Maxwell equations, TDS equations, Clausius-Clapeyron equation, and Joule-Thomson-Kelvin effect. And the unit 5 is psychometric. So psychometric properties, psychometric charts, and sensible heating, cooling, humidification, dehumidification. These are all the psychometric process. And finally we have to, what are the simple applications in psychometric. These are all the 5 units we have to discuss about in engineering thermodynamics 20 ME 302. Here we go for the unit 1, basic concepts and first law of thermodynamics. So basic concepts and first law of thermodynamics, we have to discuss about the definition of thermodynamics means thermi means heat and dynamics means power. These are all the difference. So thermodynamics is mainly deals between the heat, work and the properties of the system under equilibrium conditions. So these are all the laws which emphasize in thermodynamics. The zeroth law of thermodynamics, which deals the temperature, which means thermal equilibrium. The first law deals with the enthalpy, and second law deals with the entropy, and the third law defines the absolute zero of entropy, right? So here the two difference of the approaches, that is called, one is microscopic approach and as well as macroscopic approach. The microscopic approach, thermodynamics, is concerned directly with the structure of the matter. It is also called as a statistical thermodynamics. And the macroscopic approach, this approach thermodynamics concerned with the overall behavior of the system. It is also called as a classical thermodynamics, right? So these are all the two approaches. So next we discuss about the thermodynamic system. So system, boundary and surroundings. So these are all the three concepts. The system is a fixed quantity of matter in a particular space, and as well as boundary, it is defined as enveloping the entire system, and the surrounding, the space outside the thermodynamic system, is called surroundings. Here the image will explain the system, surrounding and the boundary. So thermodynamic systems are 3 types. So first one, it is called open system, closed system, and as well as we discuss about the system, surrounding and boundary. So what is meant by open system and a closed system? A open system can change both energy and mass with its surroundings, like for the example of water flowing in a pipe, like both mass and the kinetic energy are exchanging, that is called open system. And a closed system can exchange only energy with its surroundings, and there is no mass transfer in it, that is called closed system, like sun, right? Well, this is the example of sun, right? So here the diagram for both mass and energy, like as a system, boundary and surroundings, we are explaining in the A, both mass and energy transfers, and the B explains for only energy transfer, and the C explains for both mass and energy not transfer. That is called the boundary across not cross the system, right? So, and the final one is called isolated system. So, isolated system cannot exchange both energy and mass with its surroundings. Example, universe. So, universe is what it is, we have to explain system plus surrounding, that is called universe. So, next the topic we go for the thermodynamic property. So, thermodynamic property is classified into two types. One, it is called intensive property, and another one is called extensive property. So, any property that is independent of the mass of the system is called intensive property, like temperature and pressure. So, for example, temperature and pressure, that is independent of the mass of the system, which is console of the system, which does not transfer the energy, right? So, and extensive properties, these properties dependent on the mass of the system, like volume and enthalpy, right? So, next we go for the equilibrium concepts. First one is called thermal equilibrium, and the second one is mechanical equilibrium, and the third one is chemical equilibrium. The thermal equilibrium, which doesn't known as which we have to known as the constant temperature, and the mechanical equilibrium no unbalanced force, and the chemical equilibrium is known as no chemical reaction. So, what it is thermal equilibrium? The temperature of the system remains constant at all the point of the system with respect to time, that is called thermal equilibrium. And the mechanical equilibrium, there is no unbalanced forces and constant pressure at all points of the system with respect to time. So, all the concept it undergoes with respect to time, that is called T, right. So, how much time, minutes, seconds we have to consume, that is called we have explained in the way of time. So, chemical equilibrium, there is no chemical reaction on it, there is no chemical reaction take place, and the chemical composition will constant at all the point of the system with respect to time, right. So, these are all the three equilibrium of thermodynamics. So, next we go for the state. So, these are all the basic concept, like the approaches and the system, surrounding, boundary, and as well as equilibrium, the three types of equilibrium in thermodynamics. These are all the basic concepts, right. So, next we move to the state. The state refers to the condition of a system as described by its properties, like examples pressure and temperature. So, we have to draw the pressure versus temperature, we have to take a graph of it. So, the vertical line y axis consider as a pressure, the horizontal x axis we consider as a volume. So, we have to draw a line, that is called first one is state and second one is state. The state 1 and 2, this the line is called, the path is called the process, right. Second one, the process. A process occur when a system undergoes change in a kinetic or state of energy in a steady state condition. These are all the two type of process. So, one it is called flow process and another one it is called non-flow process. So, we all know that the what is mean by flow process. A flow process may be process in which mass entering in and leaving through the boundary of a open system. The mass entering from the boundary and leaving to the boundary are equal to the under steady state condition. So, the total mass remains constant. And we go for the non-flow process. A process may be non-flow in which fixed mass within the defined boundary undergoing a change of state, closed system undergoing the non-flow process. We go for the non-flow process in unit 1. We have several types, that is called, one it is called constant pressure and constant temperature and constant volume, and as well as isothermal or adiabatic process and polytropic process. We go for these five non-flow process we have discussed in the unit 1, right. So, next one it is called important one, that is called quasi-static process. So, what is mean by quasi-static? See, a quasi-static literally refers to almost static, and the infinite slowness of the occurrence of a process is considered as a basic premise for attaining near equilibrium in the system. That is called quasi-static process, right. So, next we go for the cycles. we have to define the cycle. So, a cycle is a series of a system. When a system in a given initial state goes through a number of different stages, different changes of a state or process, and finally returns to its initial state, the system undergone in a cycle. So, here is the explanation. So, we have to take PV. So, 1, 2, 3, 4, here are the circles. So, 1, 2, 3, 4, 1 is a cycle, and 1 to 2, 2 to 3, 3 to 4, 4 to 1 is a path, and 1 to 2, 3 to 4 is a constant volume process, and 2 to 3, 4 to 1 is a constant pressure process. These constant volume, constant pressure, constant temperature, and reversible adiabatic and polytropic process we have to discuss it in the unit 1, right. So, these are all the basic concept in engineering thermodynamics in unit 1. Thank you.